We're going to continue talking about the material inputs for standard Unreal material here in this video. So we've already seen how opacity and opacity mask work. Now I'm going to talk about world position offset. This video is going to be pretty cool. The stuff that you see here, it's going to be a lot more interesting than what we've seen before. So world position offset is really cool because it allows you to change and deform an object in real time using nothing but a material. So what could this be useful for? Well, it could be useful for doing, say, seaweed or kelp underwater and have it look like it's swaying with water as a diver swims by it. If you're doing a game that has a lot of foliage, trees, forests, that sort of thing, this is a great way of simulating getting trees and leaves and branches and tall grass to look like it's swaying with the wind gently as it moves back and forth. So if I take a one vector and just plug it in here in the world position offset, and I apply the changes and jump back in here, you're going to notice that, well, really nothing's happening. Nothing looks different. Well, that's because this works a little bit different. This is a little bit more advanced, and you can't just plug in as any node and expect it to work. So the way I'm going to get this to work, one of many thousands of ways you can get this to work, is I'm going to create a camera offset node. And don't worry about how I'm doing this stuff. The important thing is for you to see how world position offset works. So don't let yourself get too overwhelmed about what I'm doing here. This is a pretty simple example. I'm going to get a cosine node. Basically, what I'm going to create here is a little kind of mini network of nodes that are going to create movement. They're going to make action, procedural action. And then we're going to pipe that action into a world position offset in order to get our shader to do something interesting. So I'm going to take a time node, I'm going to multiply that by a constant one vector, which I'm going to change to something like 5. And I'm going to take the multiply node, I'm going to plug that into the cosine, and a cosine is a mathematics node. And you can see if I turn on my updates that it creates this sort of flashing effect. If I switch it to 2, it's going to tone that down a bit, and it's going to be a little bit simpler. That's fine. I'm going to take the output of the cosine, plug it into the offset amount of the camera offset. And then I still need something for the object center, which is a vector 3. That's going to be pretty simple. I'm just going to grab myself a 3 vector. And I'm going to go to the color, and I'm going to set the blue to 1. Red and green will be 0. I'm going to take the results of that, which is the camera offset, and I'm going to plug that into world position offset. And when I apply the changes, let's see what happens. Well, that's pretty interesting. Our little sphere is all excited now. Looks like this little guy wants to dance. Maybe we should put on some music. This would be pretty cool if you were doing something like, say, a music game, and you wanted the objects in your environment to kind of dance to the beat or something like that. It could be pretty cool. Maybe I saw one too many car commercials lately. I don't know. But anyway, this is something that I just came up with real quick in about 15 or 20 seconds while I was thinking of an example to make for this tutorial. So there's probably about 1,001 different things you can do with the world position offset. But this is just one of them, one of about 1,001 things that you can do with it. But you can see if once you start to know the material editor and start to know how all these nodes work together and start to understand the math behind it, you can start to create some pretty interesting stuff. So I'm going to make a comment here just by selecting all these nodes and hitting C for comment on the keyboard. And I'm going to rename this to funky stuff. That's pretty cool. And I'm going to move that over somewhere else, just to keep things organized and stuff like that. And it usually helps to have a more descriptive name for your comment box, not something like funky stuff, but it's just an example. Next, we're going to look at world displacement and tessellation. Now, this is a feature for DirectX 11. If you have a DirectX 11 compatible video card, then you will be able to do this. If you have an older video card or older obsolete hardware, you may not be able to do this. So assuming you do have a video card that can handle it, I'm going to go down here to Tessellation on my material parameters. By default, it'll be set to no tessellation. I'm going to set it to flat tessellation, which is the second option. There's also a PN triangles option. So, I mean, whatever method you want to use is fine. Just test them both out and see what kind of results you get. So I'm going to go with the flat tessellation. And you're going to notice now that the world displacement and the tessellation multiplier parameters are now available for us to use as inputs in the material. Now when we go back in here, we're going to notice that everything still looks the same. Nothing's changed. We haven't plugged anything into world displacement or tessellation multiplier. So world displacement, what it's going to allow us to do, it's going to allow us to, with DirectX 11, tessellate the object and displace it in real time, which is something that couldn't be done before in games, or wasn't done before in games. So what I'm going to do here is I'm just going to put in a one vector, put in a crazy number like 20, for example, for the world displacement. I'll apply the changes, jump back in here, and let's just see what happens. So you can notice that the updating process is taking a little bit longer. That's because my shader is becoming more complex. So you can notice, well, there's something really weird going on here. When I look at the object, I can see that it's being tessellated. See that? See how the wireframe looks super dense? It's being completely tessellated. So if I jump back in here, and you also notice that the object before looked like it was kind of offset and looked funny. That's because of the world displacement. World displacement is one of those things that's a lot more advanced. If you're totally new to materials in Unreal, it's going to take you a while before you really start to understand how to use world displacement. But I'll show you an example here so that you understand it a little bit better. I'm going to make copies of my texture and my texture coordinate node. That way I can get some tiling here of 4x4. Okay. I could use a texture to drive displacement, and about 95% of the time that's what you're going to want to do. So I'm going to plug this texture into the world displacement, and if we come over here, we're going to notice that nothing much has happened. So I'm going to cancel that, and we're going to make this work. And the way we're going to do that is we're going to have to hook up some other nodes. So I'm going to grab myself a vertex normal world space node, and I'm going to plug this into a multiply node. And again, you're probably sitting there wondering, well, how in the world does this guy know that you plug these nodes into each other? Well, I've been doing this for years, so I already have a good idea of what goes in what. Once you have done something so many times and you've had a lot of practice and repetition, and you've worked on games in studios, you pick up things from other people, you do R&D, you research, you figure stuff out on your own, you read documentation, figure stuff out there, and eventually you start to get better and better at it to the point where it's kind of like training wheels. You take the training wheels off the bicycle and you start riding on two wheels. So just be patient, give it time, put in the effort, the energy, and the time, and I guarantee you, you'll start to figure this stuff out, and it'll start to make sense to you. And that's pretty much the best advice I can give you. So I'm going to basically plug in all this stuff here. So I've got a vertex normal world space multiplied by a vector that's being multiplied by a texture, and then the results of all that stuff is being piped into the world displacement pin or input of my material. Now if I look at the object, you'll notice that the white checkers are now being extruded and pushed out of the object. The black checkers are just staying in place. They're not moving, they're not going anywhere, even though this whole sphere is kind of bouncing and it looks like it's ready to dance and take off. But yeah, this is tessellation. Now you notice that we had some artifacts with tessellation. That's going to be determined by a bunch of factors. So we're going to look at one of the main factors here in a moment. Okay, so down here you see the tessellation multiplier input. It's just below world displacement. We can plug in a simple one vector, a number, into that, and that's going to determine how much we tessellate this. So I'm going to set something like 10, and that's going to give us more tessellation than the default, which is going to start to get rid of a lot of the artifacts and start to make this look better. So white checkerboard squares that are popping out of the object are now, they have less artifacting, less problems. If I set that to 100, it starts to get better and better. But the higher I set that, the more expensive it is to render because you're tessellating your object more and more. So it starts to look better. So what you want to do is you want to plug a number, a one vector, into the tessellation multiplier so that you can control the amount of tessellation, multiply the tessellation, if you will, to make it look better. The other thing is the texture you're using. You want to make sure you're using a good texture. I'm using a pretty bad texture right now. This simple checkerboard texture is not a good one. But if you were using a really good one, you get better results. I'm just using this as an example to show you how world displacement and DirectX 11 tessellation works with materials in Unreal. So that is pretty much it. That's world position offset and world displacement in Unreal. It's pretty cool. Lets you do some pretty awesome stuff, pretty interesting stuff. And down here I can go to tessellation and switch to the other method, which is PN triangles. And you can, apply this one and see how this tessellates. It might do a better job, it might not, it might look the same. If I jump in here and I look at this, it looks pretty much the same right now. So the two main things affecting this is the texture and also that tessellation multiplier that we looked at earlier. So just play with those settings and get something that you like.